Hi, it's great to be here among you all. So I'm wanting to share some thoughts on what I think secure governance could look like and some tools that I believe are missing on our path towards this goal. So I'm Nico. Have been leading for the past 2 years the smart contracts team at Advancer Labs. Prior to that, I used to work at Open Zeppelin, mostly on the Open Zeppelin contracts, which is actually where many of these ideas come from. So first, I'll address the elephant in the room. Why have governance, right? Why not build permissionless decentralized systems? Why do we need to have privileged access? And that would be a goal worth striving for. But I think as of today, the industry is way too immature to tackle that problem. If you think of lending protocols, right, there's many values that are critical that need to be tuned. If you think of emergency response, that involves dealing with unforeseen scenarios. So it's very hard to design automated systems that can address all of this. So I think for the foreseeable future, privileged access will just be a thing. And it also doesn't have to be like black and white. There's a spectrum, and you can actually design systems where you don't grant like God powers to some account. I'm also going to be looking at this not through the lens of who's making decisions. That can be a CEO with a ledger, that can be on-chain voting, what have you. What I want to focus on is the fact that at some point, somewhere in the system, there will be a human looking at transaction data, and they'll need to understand the data and make a decision regarding, is this okay or is this wrong? And to some extent, answer the question, are we being hacked by accepting this data, right? Is this problematic or not? So with that out of the way, let's build a permission system. So the sort of very first design decision you'll have to deal with, which might sound minor, but it actually has important repercussions, is, are you going to have an address-based system or a permissions-based system? By address-based, what I mean is something like Open Zeppelin ownable, like you have an owner, and if that owner calls you, you can do things. That's very simple, which is its core strength. It's very easy to follow. It's very easy to figure out who the owner is. But the issue you'll have is, as you start having more and more complex behavior, you'll then have functions that look like set percentage fee, which is simple, but also shut down system, right? And you don't want to grant permission to shut down the system to the party that is setting up the percentage fees. You need to have some level of granularity. A way to do this would be to maybe say, instead of just having an owner, also have an operator, right? And they can deal with different parts of the system. However, now for every single change that you're making, every single level, tier of permissions, you need to introduce these changes in your source code. And also all of your contracts start looking sort of different because they all have different requirements. And what the owner means in one contract may have a very different meaning from what it means in a different contract. A way to work around this, which some top DeFi protocols actually do, is you'll have the owner be a smart contract itself, and then you set up the granularity, right? So the owner smart contract knows about its own owners, but then that rapidly becomes very complicated, right? The simplicity of the ownable pattern is lost, and now you have this very complex chains of contracts that you need to follow. So what is an alternative? Permissions. By permission, I simply mean anything that has the rough shape of, does the caller have permission to do the thing, right? Regardless of what permission really means, it's just following this sort of pattern. This means you'll have to define what the thing is, right? What the action is. Like you need to figure out a way to map actions in the system to say some action ID within the permissioning system. But once you go through that hurdle, what you end up is with a consistent system that always works the same because you're thinking about permissions, right? And you can have rules about how permissions work. For example, how are they granted? How are they revoked? And everything is now the same. The system scales without having to add more code. It's like you've traded the code that you add when adding new addresses for just new systems, for data, essentially. Being able to reason about properties, that apply to the entire system is incredibly useful. Especially one of my favorites is renouncing permissions, which simply means revoking your own permission. We found that extremely useful when dealing with vulnerability disclosures where we find out of an incident that involves privileged access, and we can just go very early in the triage phase and go, hey, party who has this permission, we need for you to renounce it. We cannot explain why, but you need to renounce it right away. And now we've severely mitigated the potential impact, because now that account no longer holds the permission, even though we didn't have to go through the entire governance process to revoke it, and we've severely reduced the potential severity of the issue without disclosing any, or barely any, secret information. So more concretely, what could a permission system look like? What we have at Balancer is we have a singleton contract, which we call the authorizer. It has only one relevant function, which is, can some account perform some action in this contract? And that's just a yes or no question. That is what having a permission means at Balancer. And the actions are simply based off of the function selectors of the Solidity contracts, right? We also hash them with the address to make them unique in the entire network and avoid collisions. In hindsight, we should have added also the chain ID to have even cross-network non-collisions. Alas, so this is just very simple, right? You go, okay, this makes sense. This is a sensible way to do things. So we built this, we deployed this, and then we set up a notification system, right? We went, hey, we want to know when permissions are being granted, and we want to be notified of that. And then we got a message in Slack that looks sort of like this. And we go, okay, a permission was granted. It's permission 0x12f9e0. What is that, right? Nobody knows, because that's a hash. So this sort of hints at what the first problem we're introducing is, which is there's now a layer of obscurity, right? It's now harder to understand, to reason about the system, because even though it's more consistent, there's this extra complexity. But like, okay, this is far from the end of the world. All we need to do is set up a list with all of the contracts, all of their functions, all of the permissions. We go Control F. What the F is this permission? Oh, it's change type weight on the gauge controller. Very easy, right? Not only that, we also host this on the repository, and we have CI check on every single run that all of this is correct. So it's not been tampered with. It does reflect what the on-chain contracts say their permissions are. So this is fantastic. We can reference it in governance proposals. And life is good, right? And at this point, you may ask yourself, okay, we built all of this, right? We have now permissions, and we have this system to find out what they are. Did the security of the system as a whole change in any way, right? Did we change anything? In particular, can we be hacked more or less than we could be hacked before? And naively, you might go, well, no, because malicious keys can still be compromised by malicious actors. That didn't change at all. But I would argue that compromised keys is not only the only issue, but perhaps not even the most important worry you should have. And we've increased the severity of a recent attack vector. So by revising what our threat model looked like, we identified that now there's a number of avenues that can result in critical failure. For example, what if someone goes and says, hey, I'm Nico, messages someone on Telegram and goes, we deployed this new contract. Please sign this permission, sign this action, granting this permission to this address. Trust me, I'm Nico, right? I'm leading the team, so surely I know what I'm doing. And I'm going to go on a limb and say that most multisig signers are not going to check that what I'm saying is correct. I think that is just the reality of how systems are operated. If unfortunate, that is how things often go. So this is now made worse because the permission itself is very obscure, right? It's this weird hash. So it's hard for this party to realize that this is going on. Not only that, what if they try to check, but they are sent to the wrong website? They're sent to a fake version of the Balancer site, and they don't notice that it's not the right site, so they don't realize that they're looking at a tampered version of the JSON file with the permissions. So again, now they have an issue because they're granting the wrong permission. And what if, even worse, all of this goes fine? They're very cautious, like they check that everything goes well, but random internet hijinks, the DNS cache gets poisoned, or like, I don't understand how the internet works. This is very weird, but like, you can be looking at a wrong website essentially. But that's really the point. I'm building a smart contract system. I shouldn't have to worry about the name server of the forum being configured correctly to prevent my signers from being tricked into doing the wrong thing. So is there anything I can do in my job to make this a non-issue, or to at least mitigate severity? And I think there is. There's something that all of these scenarios have in common, which is after some short period of time, the jig is up, right? Someone will notice, hey, the DNS looks weird. Like I'm accessing a wrong website. Like something is off. Or they may go, hey, it's weird that Nico messaged me on Telegram because we often talk via Slack. So I'll ask him what's up, and if was it really him, like you'll have this worrying in the back of your mind. So if by just waiting some time, this is sort of fixed, right? Because you notice that something weird happened, then what if we just force, right, everything to go through a delay? And this is something that's been talked about for a long time, delays or time locks, just in general, avoiding immediate execution, right? You go, this very important action can no longer be triggered immediately. You instead commit to an execution. It is scheduled to happen in the future after some minimum time, and critically, it can be canceled. So what this gives you is now there's a minimum time window during which you can audit what's going to happen, and you can reason about it, and you can go, hey, I think this is wrong, and I think we need to, deal with this issue. We need to better this execution because it's bad. This greatly reduces signer burden, because now what the signers sign, it's not the final. They don't have the final say anymore as to what's going to happen, and this doesn't just mean that they're protected from being, subject of phishing attacks, but also from honest mistakes. Maybe they Control-C, Control-V, the wrong permission, and now when they create the transaction, it's wrong. That's fine, because all of these things can be caught in this minimum time window. Now, this is not a panacea. It has some issues. Most obviously, if you have delays, then your system is now delayed, and you need to, not only is it slower, but you also need to choose for each action what is the delay. There's many things to consider here. I think the most important three are how urgently do you need to execute this action, right? Is this your first line of defense? Then likely, maybe you just pause the system. Likely, you don't want a delay at all. How impactful is it? If you're upgrading the system, then surely have at least some relatively large delay on your action. Otherwise, malicious an attack will immediately break your system. And something that I think is sometimes not given much thought, who is going to cancel the action in the event of an attack, and how fast can you get those people together in the room and address the issue? Because if your canceller is a 10 out of 10 multisig, odds are you're not going to get them together within, say, 48 hours. So you need to be realistic about how fast you're going to be able to react to these things. Interestingly, thinking about delays and these metrics of your system will inform often your design. So for example, if you find that you have actions that are both urgent but very impactful, right? Say you treat your mitigation for issues as just being, we'll upgrade the system, then likely that's hinting at maybe try to split those. Maybe have an urgent action that is not very impactful and try to separate that and have the actual fix happen more slowly. There may also be space for asymmetry. So for example, pausing is often not an issue, but unpausing likely means that the system was compromised in some way and therefore was paused. So you want to be 100% sure that you have fixed the issue thoroughly before you unpause. So what does this get us? We now have a system, we have permissions, they have their wrinkles, but whatever, we fix that with a file. We have delays, so we're no longer subject to phishing attacks, to DNS. Is the system secure? I think the system is reasonable and is to some extent as reasonable as can be designed on chain, but the issue is it's very complicated. The system we built has a lot of moving pieces, and there's a lot of information that is spread over multiple places, but all of that information needs to be accessed to properly use the system. And if we cannot properly use the system, then what's really happening is we cannot securely use the system, which sort of defeats the purpose of the entire exercise. So, and this is my conclusion, what I think we need and we lack in the industry as a whole, this is not something that one single team, I think, is able to tackle, is some sort of comprehensive tool that can look at all of this data that is fed, the threat model, the different actions, the design, why do these actions exist in the first place, and is able to then provide information to designers so they can figure it out, does this make sense? There's some effort in this direction. The Uniswap team built the governance seatbelt, which, as Emilio mentioned, Aave is now also using. These tools perform a couple of simple checks, such as checking, for example, that all of the all of the contracts involving a transaction have been verified, which is yeah, that's a basic standard for what's acceptable. and also try to produce, a human readable report, such as informing, in the case of this action, that the liquidation threshold for DAI is changing from 8,800 to 8,500. And that's great. That's very useful, and that's much better than transaction data. But it's still severely lacking because I don't know what a liquidation threshold is, right? I don't know under which conditions the liquidation threshold should be changed. I don't even know if this is a sensible value for the liquidation threshold. But someone knows these things, right? Whomever designed the system thought about all of these questions, and they do have the responses for those questions. But I don't see that data here, and it's very hard to get all of that together and to be able to, again, have it help me make informed decisions. So what I'm looking is for something that we can take and fit in all of that information and have it be able to respond to questions such as, what actions are currently in flight and need to be reviewed, which is not as trivial as it might seem. What are the risks associated with whatever this thing is doing? What happens if it goes wrong? How careful should we be in analyzing this? If it has a delay, why did we choose a delay in the first place, right? Should I be worried about it having a delay? Does that mean that this is impactful? If the liquidation threshold is being increased by 500, is that a sensible increase? Do we expect to increase maybe in smaller increments or not? Again, these are questions that have answers. They are just not here. And even though I started talking about different ways you can implement permissions, address versus permissions, even though each protocol has its own different kinks and they're all slightly different, what I'm talking about here is much more higher level, much more broader perspective. And I think surely it'd be easy to build some middleware layer that can just adapt the different protocols to tackle these purposes, and therefore build a tool that is just useful for all projects in all of DeFi and the entire ecosystem in general, without having to worry about those low-level details. So that's my free BC idea for you. Please go build this. When you're done, reach out so we can hire you. And yeah, thank you. That's it. There's a QR code for the slides if you want to check them out, though it seems to be slightly cropped, but hopefully it'll be able to deal with that. So yeah, thank you.